Hi everyone.
Hi.
Hello.
Hello everyone, can you hear me now?
Yes.
Okay, good. Yeah, my system audio wasn't fixed properly, I think. Um, okay, so I created a presentation based off of the content here and also the content shared by um, Lilach and Mark. Um, so I was able to come up with uh, 7 slides of content. I would like to uh, get your feedback on this, on what more we can add. The presentation is attached at the end of this document, and this document link is shared in the chat. Is everyone able to access that, or
Let me try. Would you show where is the presentation exactly? Because I cannot find it.
At the end of the, so you have this document, right, which is I already shared, and it's at the end.
At the end?
Yeah. You can see my screen?
Yeah, yeah, yeah. I don't know. I have the feeling I have the wrong
There's a link in the
link.
chat.
Oh, so
I
sorry.
just,
Yeah. I had another link to the document.
Oh yeah, this link is different from this
Okay, okay, I understand. Yeah, yeah. Thank you very much. Yeah, this is
yeah.
another one.
Yes. Okay, so I'm not sure how many slides is a requirement. Like maybe if someone can help me with that, like is there a restriction on the slides or not? But I I'm for now, like this is the content I have, like introduction of the AALC. So what is AALC sidecar? The sidecar is used for liquid cooling hardware and can be deployed in an existing air-cooled data center next to an IT hardware. And in which the sidecar heat exchanger will reject the heat from the liquid to the air and will support the IT hardware liquid cooling requirements. I'm still using the old photo here. Do we have any recommendations on new photo or like that is more what is it, either 3D or 2D diagram, or can we still use this one?
I think this representation works, but here when you explain this, what is a sidecar, maybe you have to say this is an air-assisted sidecar, the one you are represented here, because we are able to use a sidecar like a traditional sidecar, like a traditional reactor to cool down the air. So this representation here explains the air-assisted sidecar.
But I think an isometric view would be a lot easier to understand what we're actually looking at.
Yeah, which means we need to have a 3D diagram or some kind of a picture. Okay. Let me search the internet and see if I can find any 3D diagrams or 3D images to represent it. But the explanation here is where the heat is rejected from liquid to the air. So that is the key point, in my opinion, because the IT hardware will use the liquid to reject the heat, and then the liquid heat is rejected in the sidecar heat exchanger.
Yeah, but like I said, this is not a sidecar. This is an air-assisted sidecar.
Yeah, yeah.
Because the people will not know what is AALC. This is a
Do you want me to
air-assisted liquid
expand?
cooling. Yeah.
Okay.
No, you can put it. You can put there air-assisted sidecar. Yeah.
Okay. 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 To be okay. I think that makes it more clear then.
Juan, do you have a picture of your Rittal product of a traditional sidecar next to an IT rack that would work for this presentation?
Yeah, we have some images. I
Yeah,
can check it.
Yeah, I'll look for through our marketing guys and see if we've got one too. But it doesn't have to be an AALC, just a regular sidecar
Yeah,
next to an
yeah.
IT rack, and then we can just pretend it's AALC.
I think Delta has a bunch.
Yeah, yes, that's true. Oh. Yeah, they have video that explains all of this. And they also have some spec sheet of some sort. Yeah, something like this. Would this work for us?
I think something like that would be just fine. You know, that's the kind of image. You know, Juan can look, I can look and see if we've got ones, because you'd have to ask Delta for permission to use their picture.
They'll be happy. It's okay. I'll reach out to someone and then get their consent on that. Yeah, I'll reach out to them and see if I can use some of their images, or like I'll ask them to provide some better image. And the next, the sidecar form factor definition. This is something I think we kind of overlooked in the document, but when I thought about the definition of the sidecar, it can be implemented in multiple ways. The sidecar could be a single rack form factor that is sitting next to an IT rack, or multiple racks controlled using a group control and providing cooling to the IT rack, a single IT rack, or a bigger like a multi rack space, occupying sidecar with a single unit. This is more like with a bigger heat exchanger that supports the capacity, or for a better efficiency, so on and so forth. Whatever could be the reason. It could be a bigger sidecar also, whereas you're supporting for the IT gear, because like from my understanding, I have seen the sidecar going from 25 to 40 kW-ish, but with the IT rack demand going from anywhere between 40, 80 to 120, these might have to be evolved. So a single sidecar might not always support the IT hardware sitting next to it. So you might have to use a multiple racks of sidecars, or multiple sidecars for the same rack, versus a bigger sidecar for the same rack, for that particular rack. So does this make sense to like explain? Like in this, like you will have the same depth as an IT rack and same height as an IT rack, so that you won't restrict or you won't interfere with any other components that are in the data center. Whereas your width could be anything. Now you are occupying a multiple rack space in the data center versus a single rack space, something like that. Does that make sense?
Yeah, makes sense. Once, 2 years before, we spoke about by OCP in San Jose was a presentation from Meta in which they explained the sidecar assisted unit using one sidecar for 2 racks. This is also possible for sure.
Or vice versa.
Sorry?
Yeah, so that I think back then I think the IT racks are very very low density.
Yeah, I know. Therefore, today maybe is too low, but okay, yeah, you can remain. Yeah, this I think it is for the future is more
Yeah,
useful.
futuristic. Yeah, this is like moving forward. I think to enable an IT rack with an air-cooled data center, I think this could be a solution.
So just to be clear, and I guess in terms of the distinguishing between a sidecar and a CDU in that third case, because you can make the argument that the sidecar is a very small form factor and mobile or not mobile, easily installable and things like that. But if you have a very large sidecar, isn't that like a CDU, an air-cooled CDU?
I mean, like even a single sidecar could be a CDU, irrespective of like how you terminology it.
Yeah.
CDU is nothing but a cooling distribution unit, right? Most of the time, CDU is termed as a liquid to liquid cooled CDU, and more when you have air assisted that is independent of the facility water, that could be termed as like a sidecar or a heat exchanger, a large heat exchanger, and you are attaching this to a single rack, and it could be attached to multiple racks, but at the same time, we are concentrating on one rack cooling solution at this point.
Okay.
Like so, one-on-one relationship where you have one IT rack, and then you have a sizable heat exchanger next to it that is supporting that IT rack. I'm not sure if anyone have, like let's say if we have multiple IT racks and multiple sidecar solution, I don't know if that's if we can say that also, but that could be another solution where you have multiple IT racks and you have multiple sidecars, and then you combine all of them in a single manifold, where the sidecars will provide the coolant, and the IT rack to support all the IT racks that are connected to it.
If the physics makes sense, I just think once we kind of define the form factor, we just probably need to have a slide on the definition so that we're not so that there's clarity, I guess, between the sidecar versus the RPU versus the CDU.
Yeah, and RPU does exist for every sidecar. RPU doesn't go away. For every, like if you have a heat exchanger, you need to have a reservoir and pumping unit. So RPU is nothing but reservoir and pumping unit. And that exists for every one of these, because without those, like sidecar cannot function. Like that's the main, pumping system. Like I think there might be a blurred definition between a CDU and a sidecar. A sidecar can be a CDU, but not all CDUs are sidecars.
Okay.
Yeah. I'm not sure if I need to define that as one of the slides in terms of sidecar versus a CDU. Does that make sense to add that as a slide?
I would say there should be at least a line in there in the presentation, because that's one of the first things people will ask. When I have to talk about this work stream, that's one of the first things I'm asked all the time, like what the difference. And I think Michael, in the notes for the work stream proposal, that was one of the first things you said, that we need to have a proper definition. But yeah, it doesn't have to be like a long thing.
Yeah, do we have a different work stream for CDUs or no?
It's in development, but that's under the DCF. It's under John Manosh, his work group. Yeah.
Yeah, because we might have to work with them on some of these topics.
I mean, yeah, sure. If it's far along, no problem.
So basically, that's the only difference between a liquid to liquid and a liquid to air. In a liquid to liquid, you have a liquid to liquid heat exchanger, and you have an RPU like with the higher pumping units and higher flow rates. Versus in a liquid to air heat exchanger, you still are exchanging heat between liquid to air, with an RPU. So I don't think there is um, any other difference than this.
Yeah. Yeah, I've always heard of a CDU just being liquid to liquid, and a liquid to air with an RPU is a sidecar.
Yeah, we can term as that. Yeah. A CDU can be either of those, but then a sidecar is only a liquid air heat exchanger. Or we can define the terminology saying like CDU is a liquid to liquid heat exchanger with an RPU, and then sidecar is a liquid to air heat exchanger.
I think that would be better.
Okay, I think these are the definitions that we'll be sticking by for our communications.
Rajesh, one question. Do you want a picture? I found one picture for the sidecar. Maybe it works.
Oh yeah, sure. Like paste it in here, and I'll transfer it.
I can paste in the presentation maybe.
Yeah, anything is fine. Like
this in intro. Wait a moment.
Yeah, sure.
Right. I tried.
Lilach, I would be needing your help in how to explain this slide properly in terms of explaining, like I know like in the cooling side, coolant side, we can use both single phase and two phase. So I I am leaving these two slides for explaining those two. Either comparison of performance or this. Like I want to. I know this data is good. Like you gave this data based on single test point, but I'm trying to see if I can explain or kind of compare a little bit between single phase and two phase. So what is the right way to compare that in terms of the coolant? Like I know the sidecar designs are going to be completely different. Is there any way that we could explain that difference here a little bit in terms of design itself?
Well, in a single phase, the coolant never boils. On a two phase, it has to boil.
Yeah, I know, but like the coolant wise, yes, for sure. But like, how would that change some of any major components in a heat exchanger or a sidecar? How would that change? Are there any components that needs what do you say, serious modification, or like completely alter from a single phase in a two phase?
I guess you'll have different pipe sizes. It's not a component, but the vapor line would have a larger diameter. I know that there is a sorry, Lila could probably guide me here. I know for Zotaco, Sorry, go ahead.
Yeah.
Someone was gonna say something.
Yeah, I think Lilach is gonna say something. Yeah, go ahead, Leah.
No, I'm sorry, I have to drop to another call, but like I think we discussed it over the mail about the parameter that can be compared. I sent it to you 5 parameters, I think. I'm not sure.
Yeah,
It will
you sent me the performance metrics, but I'm trying to see
No,
like if I
also
can get the data on those, but
well, obviously we do have just the data about the two-phase because that's what we're doing. But well, I'm sorry, I just have to drop to another call. But you shared, I have the link for the slides. It's not the template yet, I see. It's not the template of the OCP yet, but
yeah.
okay, let me think about it and we will insert relevant information about the two-phase.
Yeah, I'd like to, have a comparison or like what are the major component differences that you would see between single phase and a two phase.
Okay.
Actually,
Okay. So
yeah.
maybe you can add a slide with this headline. So we will.
Okay, I will.
Okay.
And
Okay,
yeah,
thank you.
and if you can
Right.
write like a small paragraph for me on this, that would be great too. Like
Okay.
explaining this.
Okay.
Yeah.
Thank you. Sorry, and
Yeah.
I have to
Yeah.
go. Thank you.
Yeah, sure.
Bye.
Thank you.
Rajesh, one question. I have not. I cannot edit this PowerPoint. Therefore, I cannot paste nothing there. I sent to you the request to be able to modify or to edit this presentation, but I paste the picture in the Word data in the Word in the white paper. Yeah, at the end.
Let me see. Okay. Editor. Okay. I think now you can edit it. I'm really sorry.
Okay.
Yeah.
Okay.
I had to change some
On the
permissions. I
end.
didn't realize. Yeah. Okay.
Yeah, this one. And you can see really easy that the cold air is coming into the sidecar and going out warm air. And in that case, I think everyone will know that how it's working more or less. But sometimes it's difficult to understand what is the purpose of this system.
Okay. Let's see. Oh.
In your diagram, you can just flip the position of the IT gear and the RPU on there so it matches the picture.
You can move it and make symmetrical, I think.
Yeah.
The photo you can copy and make, yeah. That way will work better.
Yeah. Okay. I think this is good. Yeah. Yeah. But these IT gear are like I know these IT gear, but like those are air cooled, so it's
Yeah,
for
I
me.
said this IT gear, you have one place in which you have nothing to show that the warm air is going from the back now.
Yeah. Okay. I think this will do. I'll try to rearrange this and then maybe I'll just crop this a little bit and then have only the top view so that it's easy to understand or reduce. Okay.
There actually is if that same image, I think it's cropped, but if you expand it, it should. Oh wait, no, that's the door-heat-exchanger. It doesn't show the airflow. You're right. Okay,
No,
never mind.
yeah, that's a different. Yeah, that's a radar heat exchanger. Okay. Does this make sense then? A little bit. Okay. Yeah, and like Jabari, I think where can I download the format for OCP, like the OCP template?
I actually just shared it with all the workstream leads, so you'll have
Okay.
an email here with an invitation to Google Slides document with the formatted slides.
Okay then. I'll just transfer the content to that like once I'm done here.
Yeah, no problem. It's
Yeah.
you, Juan Carlos, Michael, and Lilac, I believe, would have received it. And if you want me to move this file as well, well, I can give you access to the Google Drive for OCP so that you can put this in there. But anyway, I mean, it depends on what works for you.
Yeah.
So yeah.
And that's a two-phase and single phase. I think it's going to be a quick slide. And after that, I haven't covered other section on the design. So like there is control aspects of it that we talked over here. Oh yeah, I forgot. Like I was talking to Lilac earlier, and then I skipped this slide. Okay, the design criteria. So the design criteria has a three different component list that I think we discussed last week. So the critical components, non-critical components, and single point of failure critical components. And we defined the definition for those and also some of the examples. So briefly, talking on what does the critical component mean and all of that, like, does this suffice or should we add any more details for the listener to understand?
Yeah, I think it is.
So just out of curiosity, because I know this was the last meeting that we discussed the non-critical components. What was the thinking behind including that particular category, that in non-critical? Was it to emphasize that that they are hot swappable, or like what was?
Yeah, hard swappability. That's what I was gonna add.
Okay.
Usually the critical components should be redundant.
Yeah, should redundant and hot swappable.
Not, I think hot swappable is not a criteria, but a criteria is to have redundant components in case one fails. You have full redundancy to be able to run the system until service is coming.
So redundancy is good enough, not hot swappability.
Hot swappable is nice to have in that case, but I think depend of the customers what they want.
Okay, does this make sense then? Should have redundancy and could have hot swappability. Okay. Because in the designs I have seen, all of these components are hot swappable. At least like to my knowledge of the designs that I have seen. And filters, sometimes they are, sometimes they're not, but like usually pumps, fans, and PSUs are definitely hot swappable. Yes. So this is to define like what are the components that like that needs to be categorized, and also should be designed, like keep this in mind while designing itself, in the design criteria. And this will set the stage for how they talk about the design components, for the future presentations or to our paper actually. Okay. And yeah.
I think this is in that way. It's okay. Also, non-critical components are, usually you can make it hot swappable to be able to change it in case it's not working. But in that case, you don't need redundancy, for example, like with critical components. You can use only one temperature sensor. In case it's not working, you can change it.
Yeah, you can change it, but the thing is, in the meantime, it has to have the capacity to serve the design load, right?
Yeah. Therefore, it's not critical because there is another way to maintain the system working without the temperature sensor, for example.
Yes, that's true. That's true. There is a way to work this. So that's why this can be replaced, but not necessarily hot swappable.
No, not necessarily redundant.
Not necessarily redundant. Yeah, I didn't. Okay. So instead of hot swappability, you wanna change that to redundancy?
I think so. This is the non-critical components are this particular point that you don't need to make it redundant because the system will work without this component. So you don't need to spend more money to keep the system running because you are able to run the system without this component.
Yeah.
Is the idea behind. So you don't need it make redundant, but it's nice to have to be able to replace it because usually it's not as difficult.
Okay. 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 Cool. This makes sense. Next is the coolant. Like there will be two different types of it can be cooled with two different type of liquid, single phase and two phase, and then some differences. I'll touch base with Lash again and then see if I can write out some details here. But for now, I'll keep this as a placeholder. And the data that she provided only indicates one thing, that as the inlet temperature goes up, the saturation temperature raises, and what does that mean to the system, and the heat capacity, like the heat loads will also, I think, change. So I need to a little bit understand more about it from her on what kind of message we want to give, set this in terms of like presenting, because like in a regular system, if the supply temperature goes up, you have certain approach temperature, which means your coolant temperature goes up. So in turn, you have certain limitations. But in this, your supply temperature, your coolant temperature doesn't change much, I guess. But your coolant capacity might change. So I need to find out what is that relationship, and then I'll write it down. And after this, followed by the radar heat exchanger and sidecar. This is where we've been helped with this data, and their test data. They try to be more normalized by sharing only the power, like how the power changes with different powers that they tested with, like single 8K server, two and then three servers in a rack, and then how that power consumption comparative. Mark is here. Like, do you have like any what do you say, like data that you can share that could help us compare two-phase and single-phase, such as chip power versus like cooling?
But I think there is no differences at all. Also, there is not a big difference between these two technologies, because the graphic you are seeing in the page 6.
Oh, this is
Yeah.
two-phase completely, right?
Yeah. But this is the performance data of one specific sidecar. But you can change the heat exchanger and you will have another performance. So this is not a general graphic for general sidecars with two-phase. This one specific two-phase sidecar, I think.
Yes,
Because
that's
this
true.
is showing only the approach between the condensing temperature of the two-phase refrigerant and the air temperature. There's
Okay.
nothing more. There's like a condenser. You are saying in there how much power have the heat exchanger. One heat exchanger, defined heat exchanger by different air temperatures and different power, and then you get the approach. But if you think about when you are using liquid cooling with one phase, is almost the same. If you get one heat exchanger, with this heat exchanger, you will get also similar graph. So with not saturation temperatures, but with liquid temperatures. And at the end, you will have an approach. The approach will be very low if the required power is very low. If the required power is really high, you will increase the approach for sure. And this is almost the same with one phase or two phases. It's not a very big difference. The only differences are in how you how you make the system. In two phase, you have a condenser. In one phase, you have not a condenser. You have only a liquid to air heat exchanger. If you are using two phase, you need special pumping units or special reservoir, because the pumps are not working with gas. So you have to take care that the liquid is on the pump and not the gas. In case one phase liquid cooling, usually you don't have this problem. Yes, you can have some bubbles, something like that, but usually if the pump is near to the bottom, you never will have something like that. But the performance of the heat exchanger is not much different, and this is at the end the case.
Yeah, the heat exchanger could be similar but not same, because so
No, same
your
is not. It's
yeah,
different. The
yeah,
connections are different for sure, but the performance, the performance will be similar.
similar.
Yeah.
Okay. Yeah, but yeah, I am trying to see how can I compare those two performances. That's the idea. Like, a little bit of a performance difference between like two-phase and single-phase in terms of I had to capture one commonality. Like in Relatch, like I asked her Relatch, and then she gave me some details on like how it can be done. Per se, for example, okay. Yeah, she was talking me about the condenser surface area, the fan power consumption, the maximum power load, and the temperature. So these are some of the things that we can compare. But
But in that case, you will compare two solutions, but not two general technologies. And this is the main difference.
Yeah, I think you'd be better off having a chart that would show cooling capacity versus air inlet temperature, and then have one line that would represent two-phase and one line that would represent single-phase.
but they should have same heat exchanger, which is
Yeah,
not possible.
yeah, we want to compare technologies, not solutions.
Okay.
Because you can put there one small heat exchanger on you, for sure, you will get less power. But you want to compare two technologies, and it's really difficult because
Yeah.
you cannot use the same heat exchanger. But from the air side, if you are using 10 kilowatts with a delta T of the air of 10 Kelvin, almost will be the same for the technology. Differences will be on the side of the air side, no differences, because you have a heat exchanger, you have a pressure drop, you have a flow rate, and flow rate pressure drop makes the fan make the efficiency of the system. So you will not have a big differences, I think.
So why would you want to use two-phase?
Have some advantages.
So basically, the one of the advantage that I have seen is for the same heat exchanger surface area, two-phase can reject more heat than a single phase.
I don't know. I'm not pretty sure. It depends more about the technology. For example, microchannel. Only with if you change to microchannel, you get more power. But not this because of one phase or two phase. This is because microchannel is better than thin and tubes.
I see.
So I think we need like a marketing presentation here, not a technology presentation. I mean, it's
Yeah,
true. You know, why would you ever want two-phase?
Yeah, this depends of the customers. So we don't. I think all technology have some pros and some cons, no? And
Yeah, well,
two-phase have the ability to have leakages without produce damages, for example. This is one. But the liquid with water is everything, from my point of view, more easy. But that is something Sutako should explain more in detail with two-phase.
I think when you mentioned the comparing technologies, you were really talking about performance, right? So when you're talking about all these other things that you need to consider, I mean, that's true, but what we're starting with is the performance of the technology. So I think that's where Michael's coming from, I think, with the marketing.
Yeah.
So
I mean,
saying, hey, go ahead, Michael.
For given physical size of sidecar, would a two-phase sidecar cool more than a single-phase sidecar?
I don't think so.
I think Lalak would probably disagree with you.
She will.
But that I think is the point of this. Is that if you're, floor space is very, very important in the data center and expensive. So if you can get more cooling for the same physical space with a two-phase coolant than a single-phase coolant, then that, from a marketing perspective, that's a good reason to consider two-phase. But if the cooling capacity is identical, then I don't see the point of two-phase.
It's at the chiplet level.
But if you're going to use, if you need something like microchannel for the two-phase for the cold plate, but it's an unfair comparison to not also use microchannel for the single-phase coolant. And at that point is a cold plate for single phase and two phase going to have nearly the same energy absorption capacity?
You're going into too much technical details where, like, if you introduce microchannels, that's going to increase the pressure drop at the pump, and that's going to increase the pumping power of the whole system.
But it's not the case. You can put many channels in parallel as you want and reduce the pressure drop in the microchannel. So at least the microchannel heat exchanger is much better because with the same pressure drop, you are able to transfer more energy because of the corrugated fins and the way they put the fins.
Yeah,
and
it's
the
just larger
tubes.
contact area between the coolant and the metal.
Yeah, it's very
Okay.
much efficient than the fin and tubes. The tubes are a very old technology, but you can use copper and for copper heated plate cold plates. You can use a microchannel with aluminum, but some customers don't want to use it. Yeah, in that case, only in that case, but this is because of the technology of the microchannel is better two-phase, because two-phase are refrigerant. Refrigerant are not conductive. In that case, you could use aluminum in one side of the system and copper in the other side, more easier. But from my point of view, with liquid one phase is also possible. But some customers are afraid of that, to combine copper and aluminum.
So this
Yeah,
is
for
getting
single
down.
phase for sure.
Yeah. So this is getting to a practical matter as to for maybe long-term viability of the product or maintenance of the product as to whether you go two-phase or single phase.
Well, I mean, I don't think we need to go to that level, right? I think what needs to happen, and I saw Mark and Amruta, you guys, I think they're both on WeWin. You guys were unmuted for a while. I think you wanted to say something. So, I mean, if you want to jump in, it's fine. But if you have information on the single phase side of things, and Lilac has information on the two phase, then it's just a matter of deciding where the whole points are, like where you're going to be consistent so that you can compare the two performances. And it's just a matter of agreeing, if it's microchannel, if it's the or what type of heat exchanger, etc. And just agreeing on those two sides from WeWin versus not even from the single phase versus the two phase with SusaCore.
But other than the actual implementation of the sidecar, is there any big performance difference in the cooling between, both using microchannel? Any big performance difference between two phase and single phase?
I don't know. Mark, do you have an answer to that? Or you wanted to say something else?
No, I just have a question that
okay.
What is the difference between single phase and two phase for sidecar? They just changed the coolant to from single phase to two phase, or
not only you have to change many parts of the system, but
for my experience, I know two phase system have the condenser, right? So in the sidecar, they also add the condenser for the two phase sidecar.
Yeah, so basically in a two phase, you will, yes, the liquids are different. So as some of the components inside, you will still have the similar heat exchanger, like the microchannel heat exchanger that Juan was talking about. But some of the components will change and the order of the components will change based on like you don't want any leakages, and then you want all the fluid to be condensed to the reservoir, and then you start pumping, and how you place your filter would change. So there are some technicalities in terms of how they arrange it, but at the end of the day, we are trying to make sure that it fits into a single sidecar solution or a rack solution, or the form factor that we are defining it to, and then then the performance comparison will come into play. In the same form factor, how would that perform?
Okay, I think I don't have any data or experience, but I will grab this information and have a discussion with Jalen.
Okay. Got it.
Yeah,
Yeah.
you haven't sold me on this technology yet. So if I'm a new customer and I'm evaluating, I've decided to go sidecar because I have more energy in my IT cabinet than can be accommodated by a rear door heat exchanger. So I know I need a sidecar. Sell me on single phase versus two phase.
Well, okay, two selling points, right? One is the sidecar itself, single phase, and then the other selling point is single phase versus two phase. So maybe that's right, Rajesh. Maybe we need to distinguish those two benefits and have slides on both of those.
Yeah, so one is on sidecar as a technology, and I think it's independent of whether it's single phase or two phase. And the big selling feature is more capacity, that you can get more cooling out of a sidecar than you can out of a rear door heat exchanger. So that's one point. But now you've sold me on a sidecar. Sell me on single phase versus two phase.
So basically, it's the technology of the cooling chip. Like if the chip is good enough, because at the chip level, you have power densities. If the power density is low enough to handle by a single phase, you can. Sometimes, like the power densities on the chip level is much higher, you would need a two phase versus a single phase. That's when you would need two phase cooling.
Okay, so that's exactly what needs to be in this presentation then, is that we have two critical points. One is we've got some upper limit of cooling capacity for a rear door heat exchanger, and when you cross that, you need to go sidecar so that you can have physically a larger heat exchanger. But then, so now you've sold me on sidecar, and then the next critical point is what the TPD is of the chips that I've got. And there's going to be some point on there for how many watts my CPUs and GPUs and stuff are consuming, and whether it's possible or safe to cool it with a single phase coolant, or whether the TPD is so high that the only way to cool it is with a two phase.
But this is the case. This is a big question. If the only way to cool down the cold plate is with two phase and not with one phase, because I am not sure. I think both technologies are good enough to increase the power as much you want. Yeah, for sure there is a limit, but a limit for both of them.
Yes,
Well,
there is a limit. Yes.
Yeah, NVIDIA is talking about 1,000-watt chips.
Do you think it's not possible? It's possible with watts as well.
Yes, 1,000 watts is possible. Up to, I think, something around 2,000 watts-ish. It's possible, but there is a point where it breaks, and then you have to move to two phase, partially because you cannot reduce the temperatures that much with single phase. Your two phase, your boiling point is the same, so irrespective of like as long as the liquid is in a liquid state, it will cool the chip to the lower temperatures than a single phase. So there is some differences in that.
So maybe this is what the slide needs to have. It needs to say, okay, if you're going from 0 to 40 kilowatts, 80 kilowatts, pick a number, the system can be cooled with a rear door heat exchanger. And if you're above, pick a number, then you don't have a large enough heat exchanger on the back of the cabinet. So the way to solve that problem is to go to a sidecar so that you can have a physically larger a heat exchanger, and then that gets you from 80 kilowatts.
I want to say numbers, but it's right now it's a blur. There is no definite guidelines in terms of telling, hey, this is the power that the single phase would stop cooling, and that's where two phase starts. There is an overlap, and also the technology on the two phase is still being developed at a higher scale. We don't have those numbers yet.
But
so that's
what goes on the slide. It is that we could probably pick the number for where you transition from a rear door heat exchanger to a sidecar, but then it sounds like the kilowatt chips, which are a year or two away, can still be cooled with the sidecar with single phase coolant. So the driving force to go to a 2-phase coolant where single phase won't work anymore sounds like it might be 5 years away. But there is potentially some point in the future where, and we don't know whether it's 3 kilowatts or 4 kilowatts or something like that per chip, where the single phase may not work anymore. And I think that's what you can put on the slide, is that the technology is new, but the technology does exist to handle chips that are going to be introduced 2 or 3 years from now.
Yeah, the problem is the problem is not the power per chip. If it is 2 kilowatts, but the surface of this chip is 2 times 1 kilowatt chips, it is the same. Also, at least you have a problem with the power density, power per
centimeter square.
Yeah.
Per centimeter square.
If you increase the power per chip and increase the size, you can go with the same technology, the same cold plates, but bigger. And in the second, if you are using water in the cold plate, or let me say 2-phase refrigerant, at the end you have the same heat transfer units. Also, you have the same heat transfer through the fins. Usually 2, 3, 4,000 watts per Kelvin quadrat meter. This is for both technologies are almost the same. The only difference I could say is, okay, you need a smaller pump, because when you put liquid into the cold plate, then evaporate, and you are using the evaporation enthalpy and not the sensible enthalpy. But and in that case, you need less pumping power. The pumps are smaller. But from the other side, the gas takes more volume than water, so you need bigger pipes than water in that case. So compensate a little bit.
And you also need a reservoir.
In both cases, you need a reservoir. Yeah.
So for a cold plate, are there conditions for the amount of energy absorption capacity that 2-phase is higher than single phase?
Sorry, say it again, the question.
For a given physical size of cold plate, can you cool more with 2-phase than single phase?
I don't think so.
Well, that's still debatable. Like people would say yes. Like I think it's still under development. We cannot confirm. Yeah.
You can compare a plate heat exchanger as evaporator or a plate heat exchanger as liquid to liquid. You will see there's no differences.
So we're back to, you haven't sold me on 2-phase coolant yet.
Nope.
No, I think if Zootacora here, they would disagree vociferously. So, does Juan Carlos or Rital do 2-phase as commercially?
No.
Okay,
I know both technologies.
I don't doubt you. You're a genius. Okay.
No, we are doing 1-phase, but Zootacora is partner from Rital doing 2-phase. But
okay.
I know both technologies, and this is the only thing I can say. But 2-phase had also advantages, like 1-phase.
So we're back to marketing.
Yep.
Let's get the slides up, and then we could let's put the information on, even the ones what we disagree with. All right, and then we get debated, because we have time between when it's submitted and when we get the comments back. I wanted to ask Wewin, I guess Mark, it's gonna be two people presenting, right? It's gonna be Rajesh and someone from Wewin. Is that you, Mark?
I think it's Jalen.
Jalen? Okay.
Yeah. Jalen or
Rajesh.
In my opinion.
Let's put Jalen's name, Rajesh, because when you submit it, you have to add his the presenter's name. Okay, so I can give you his email address, so he'll get the email once the comments come back.
Yeah. I will yeah, for now, these two are the only slides I have. So I requested for some more data, like via email. So I'm gonna add that and also kind of present like I'm gonna make like at least 3 slides of these to for the presentation. And the comparisons we're doing it here are like power consumption, airflow rate comparison, and also how would that impact the overall cooling. Yeah, so
Plus the marketing slide, right? It's
yeah,
additional. Okay.
there is one more slide that I'm requesting on the power and also some airflow rates that I'm requesting. I'll add that later. Hopefully, like I think I got a reply from Jalin. Jalen. He said like he might be out of the office and he'll try to get back to me um by the end of this week or next week sometime. So I'm not waiting for them for that. I'm just gonna submit with this content. Is this content good enough for submission?
Let's when we have all the slides in, we can have a call on Friday or Monday.
No,
Just to
I had to submit by 26th, which means this is the review.
No, I mean
The
to
Monday. On Monday is the last day you can
Yeah.
submit this presentation.
Yes, Monday is the last day. So I'm guessing we will be meeting on the 29th, but I'll be submitting sometime either on Sunday or Monday this presentation.
Yeah,
So
if you want, we can take a meeting on Monday or something like that to review the presentation.
Yeah, but I haven't heard any major changes on the slides in order for me to make changes. The only thing is that there is the coolant side is something I have heard some modifications, which I'll work on this. But apart from that, is there any content that I need to add into the slides or modify? That is something I want your feedback on.
We can do that. So you need feedback from us about these slides, you mean?
Yeah, so what kind of content that I need to add more? So there is a lot of content here, right? So I try to I add the first definition section, and after that a little bit of performance. But
Yeah.
I need more
You
feedback.
also, I think you don't need to put the white paper here in this presentation because we are not ready with
Yes.
the white paper. So the first point you can show some results and so on, but the main idea behind that is to show what we are doing and which is the purpose of this white paper. We want to write a specification like we did for the rear door and so on. You don't need to post all the results we will get in the white paper. Yeah, you have to show only what we are doing or we want to do and ask for help for other participants.
Okay. So in that case, I'm gonna link some resources here to our meetings and also
there's a slide for that in the template that I sent, right? So in terms of what needs, sorry, on Carlos.
I don't want to say nothing. No.
Okay, no, I was gonna say so you said you had to add a slide on the power. We also had to add some info on the definition, and then we also had the marketing quote unquote slides for the sidecar technology versus the single phase, two phase. Right.
Yeah.
So those were 4 things that had to be added, right? So that's why I was saying if you want to meet up again on Monday before you submit, it's fine. We can make, because I don't think that'll take that long.
Yeah, I don't have the content for those to add.
Okay,
That's
it's
why.
fine. You can put the intent of the slide and state that I mean, it's not ideal, but people will understand if I explain to them.
Okay, cool.
Yeah.
Yeah.
One point about this slide here. If we saw that the sidecar consumes more energy because you have the fans there and so on, you have to consider that the CDU have the fans outside the building. Therefore, the consumption is less because you are not considering the fans outside the building. So this is an important point.
Oh, but the sidecar is only cooling the liquid, right?
With fans.
With
But
fans.
in a CDU, you have
Uh-huh.
on the primary side also a free cooling system with fans. But you are not considering this part in the power consumption, and therefore is the power consumption of the CDU, I don't know, 10% of the consumption of the rear door heat exchanger or the sidecar, I think. And this idea should
So
be.
you're saying this is not apple to apple comparison.
You can compare it, but after that you can say, okay, but outside the building you have also fans and heat exchanger like the rear door to cool down the primary cooling circuit, and it takes energy, and I didn't consider that here in this picture.
But aren't you counting it twice? Because you're taking the air that's being used at the sidecar is also being cooled by the chiller system.
Yeah.
So you're counting it
Whatever.
twice.
Sometimes you have only in the north of Europe there are many data centers which have not really chillers. They are only using adiabatic cooling and nothing.
Yeah, but in my opinion, what I thought is in a radial heat exchanger, you have air supplied from the chillers or the cryonets come to the hardware, and then that will cool the hardware peripherals, and then it will cool the liquid from the radial heat exchanger, and after that it will release the hot air into the hot aisle. But where the radial heat exchanger is supposed to only cool the liquid that is coming out of the system, and that's exactly what the sidecar is also doing, but next to being next to it and having a bigger heat exchanger in that place. So am I missing something in that?
No, technically there's no difference between a hybrid rear door heat exchanger and a sidecar other than capacity.
That's what I thought. Yeah.
Air assisted, you mean? The hybrid is the traditional rear door with a CDU.
Yes.
So basically, I think
the middle one.
We are talking about
the middle one. This is the air assisted.
The middle one, yes, air assisted. This is the only case that we are talking in this.
Right.
We
the
are
only difference is
one.
you get a bigger heat exchanger with a sidecar than you can fit with a rear door heat exchanger.
Exactly.
And another, not a big difference, but important, is the rear door is getting warm air from the IT gear. In the sidecar, you are taking the lowest temperature it's possible to get. And maybe it's only 5 Kelvin. It's not too much, but
there is a difference, right? But the percentage of cooling load that's left over from air cooling should be very, very small compared to the liquid cooling. You would expect that maybe 80 or 90% of the total cooling load would be liquid, and just a little bit of the rest would be air.
Yeah, depends. How is the server? Sometimes it's 50-50, sometimes it's 90% liquid cooling.
Yeah. Well, maybe that's a point that ought to go into the presentation. But it doesn't. Well, that actually isn't.
We can
interesting.
We can state that, hey, like Mark, like, is there any way that we can say, hey, 90% of, like, when you are doing this test, like, can you say like 90% of the heat load is taken by the liquid, or 80% is taken by the liquid? Is there any percentage that we can associate?
Yeah, it's just
between 50 and 90. It is the normal thing.
yeah, but closer.
He's asking Mark. He was asking Mark.
Yeah, but when you get closer to 90,
sorry.
then the comparison between a rear door heat exchanger and a sidecar gets easier.
Yeah,
Yeah.
Mark.
I think this result only only transfer the liquid to the cold plate. So most of the power is cooled by CDU. Is that
Okay.
what you are asking?
Yeah, it's for a server. Are you cooling, DIMMs, GPUs, FPGAs, Southbridge CPUs, everything like that, and then there's just a little bit of glue logic left over that's air cooled. So it might be 10% or something like that of the total.
Yeah, so these results are, I think, is like cool for the GPU.
So can we say this is like 80% liquid cooled?
Yeah, put a range. There is not a one value which is right.
Okay.
There is a range.
But we can pick a value for the comparison.
Yeah, because
for
only for this one, because these test results are done by Vivin, right? So they already know what is the percentage from this test results.
So yeah. Okay, in that case,
yeah,
we have to ask. Yeah.
But in my opinion, I think it's 100% because there's no other components for by the air.
You're using
there's
TTVs?
only the TTV. Yeah.
Okay.
In this result, but I will ask Jalen to make sure the information is correct.
Yeah, it's probably not 100. It's probably 90 or 95 or something like that.
There is another point to be considered. Usually servers which are near to 100% liquid cooled, they don't think about to cool down with air. So they don't let the space in the IT gear to go through with the air through the server. So if you put a rear door there and the servers are closed because they don't need air, you cannot move the air through the servers. So the rear door will have a big problem to move the air through the servers because everything is closed. Therefore, in that case, in the future will be the sidecar, in that case only, will be the sidecar the most suitable technology to be able to cool down the servers.
Yeah. So Mark, can you confirm this to me, like in the next meeting or by email, like how much percentage? Because there would be, like, even though if you are using TTVs, there will be, is there any VRs that are on their board or power converters or PSUs that you used?
Okay, I got it. I will ask Jalen because I think this power on the picture only count for the TTV, and I'm not sure there's other component power.
Yeah. Please confirm that and let me know. Like, just give me a percentage. You don't have to give me the numbers. That's good enough. So it could be somewhere close to 90, between 90 and 100. I would let you comment on that. Yeah.
Okay.
Yeah. So as this is a TTV system, I totally understand how the design could be and what. So there is no other components except just GPU powers. Okay, that makes sense.
I have another question. I'm doing this presentation for the interface, also the rear door interfaces, and I wanted to ask you if you can help me tomorrow or Monday to take an overview about the presentation.
Oh, sure. Yeah.
I am asking everyone if have a time at the
sure, no problem.
Monday or Friday, I don't know.
Yeah, whenever you're ready to have a review, I guess you could. I'm available and I'll make time.
Is that 8 o'clock or 9 o'clock? Okay. Tomorrow or on Monday?
9 should be good enough for me.
You're talking which time zone?
The Pacific time, yeah.
Perfect.
Oh, okay. Yeah, that's fine.
Yeah, 9 would be good enough for me.
Tomorrow?
Yeah, tomorrow or Monday, either would work. Today I'm gonna work on a little bit touch-ups on this. Yeah. Tomorrow or Monday, just pick a time.
9:30. I have a meeting at 9, I think, but from 9:30 after that, I'll be free.
So I can put it out at 9:30 if you want.
Okay,
Okay.
no problem.
For you, Mark, Michael, Ryan, it's okay?
I think I'm okay.
Yep, I'm
But
okay.
yeah, sure.
Okay, I appreciate it. Thank you very much.
No problem.
But you will send me the link.
The link to the white paper is somewhere, I don't know. But yeah, I can send also the link. Yeah. For the presentation, I have not a link. I have something. But tomorrow I will show you. Yeah.
Okay.
And the link, wait a moment, I can do something. The link to the interface white paper, I let it in the chat. Yeah. For the presentation tomorrow, I will be almost ready.
Okay.
And the meeting. So
Invitation.
the meeting, yeah, it's the same link.
Yes. Jabari, we can do that per Teams. I can send an invitation per Teams, or we have to do that with Zoom.
For this kind of just touching,
Do you want to use the same link?
we can use this same link. Hold on, give me a sec. Because I think Anne-Catherine set this up, right? So sometimes I have trouble trying to edit. Let me. We will sort it out and send an invitation for the call. Okay, don't worry.
Okay. Thank you. Jabari.
Okay.
Cool.
9:30. Yeah.
Okay, no problem.
Rajesh, if you need our help for tomorrow or Monday, send a meeting and we can continue with this meeting.
Yeah, actually, don't worry about using the official OCP thing for this, because if it's gonna take too long or it's too complicated and it's just 1 or 2 days, it doesn't matter. So just yeah, well, whatever works. But I'll try to send out something pretty soon for the interfaces. Rajesh, do you need help with the sidecar, or are you just gonna send one out when you're ready?
I think by when we meet tomorrow, we will take maybe 10 to 15 minutes in the same meeting. I'll try to make some changes to this, and then I'll use that to submit.
Okay, no problem.
Okay. Cool.
All right,
okay.
guys.
Thank you. Yeah, we're like half an hour over.
Yeah.
This is a great discussion. I really appreciate all your time. Thank you, folks. Yeah.
Yeah.
1 second, I have a question.
Yeah.
Yeah.
Rajesh, so you will not wait for the Jalen reply for the new experiment results? You will just submit.
I have to submit by 26th. If he can reply within this weekend, I'll wait, and then I'll add that content. If not, I have to definitely submit on the 26th. I'll wait until then.
Okay, I got it. I will send him a message.
Okay, thank you.
Okay, no problem.
Okay, thanks, guys.
Okay, thank you. Bye-bye.
Thank you. Bye-bye.
Bye-bye, guys.